We're going to look at heat engines and combustion today. Okay, so we're going to talk about the 3 laws of thermal physics. I want you to know what they are so you can talk about them at the cocktail party. Energy has to be conserved. So the energy and heat that you put in has to be equal to the energy and heat that you put out. What this means is the work that goes into a machine plus the fuel is going to be equal to the work that the machine puts out plus the heat, the waste heat. Now, because we don't normally talk about the work that you put in, we just subtract that work from this work, we see that the fuel you put in is equal to the work you get out plus the waste heat, or fuel in equals the work out plus the heat, the cool heat given off in the exhaust, right? Because the heat given off in the exhaust is cooler than the real hot heat in the exploding combustion chamber. The second law is entropy, disorder can only increase. So what this means is if you walk into your house and you say this is a mess and you drop a bomb and it blows up, it's not going to result. There's no way that it will spontaneously result in a more ordered house. A very important consequence of this is heat must always flow from hot to cold. You never see it go the other way spontaneously, and we'll talk about that in a moment. The third law, just know what it is. It's something about absolute zero, which is 0 Kelvin or negative 273 Celsius. And it's where entropy is minimized and you can't ever really get there. So all this means to us is as you cool things down, the disorder, the entropy decreases. It's the first two that are very important for us and for our machines. The violation of these 2 laws, well, you can't violate these 2 laws, but people try to with perpetual motion machines that are fraudulent. So let's look at them. Someone approaches me, and this happens to me. Hey, so my friend has this new engine that you put in a car and it produces power and you don't have to put anything in. And I say, great, when you get it running, come by and pick me up. Because I know you can't violate the first law of thermal. You have to conserve energy. This is called a perpetual motion machine of the first kind. They don't exist. If someone tries to get you to invest your money in it, show them the door. The second law of thermal is that entropy, disorder, always increases. So for instance, if you had a blue gas and a red gas, the molecules would intermix, they become disordered, and you'd have purple. It would never go the other way. So what about if you had hot molecules and cold molecules? What would happen? The heat would flow from hot to cold. So for instance, if you had an ice cube melting in some water, the heat from the hot water would go to melt the ice cube. It would never go the other way. Or if you had a hot block in contact with a cold block, the heat would flow from hot to cold. Heat wants to flow from hot to cold. Now, when it flows from hot to cold, your entropy is increased, the disorder is increased. And this could be thought of as a machine with the efficiency of 0, because you've let the heat flow from hot to cold, but you haven't gotten any work from it. So this gives rise to another class of perpetual motion machines. Someone says, hey, I've got this box and it produces electricity or some kind of energy. And the energy comes from the room, so the box just makes the room cold. And you realize this can't happen because it violates the second law. You can't just cool down a room and reduce the order of the room and make energy from it. You need to have waste heat. And so now you have heat flowing from hot to cold. So that has increased the disorder because you have heat flowing from hot to cold. And you're able to get some work out. And so we can think of an engine, a heat engine, as making use of the fact that heat wants to flow from hot to cold, and in doing so, we can make it do some work. Even a completely frictionless machine won't give you 100% efficiency. So on the test, when I say, why can't you have a 100% efficiency machine? The answer is not that you always have friction. That's true. But the issue is that you always have to have heat flow from hot to cold, so you always need to have waste heat. Now, we can derive in physics, and we won't do it now, is that the perfect efficiency that you can get is called your Carnot efficiency, because this guy named Carnot, a Frenchman, discovered it. And that efficiency is equal to the hot temperature minus the cold temperature divided by the hot temperature. And that would be the hot temperature here and the cold temperature of your exhaust. We can simplify this to say the efficiency is equal to 100% minus this ratio. So in order to maximize your efficiency, you want your cold temperature to be cold as possible, and you want your hot temperature to be hotter than hell. How hot? Well, not so hot that it melts the pipes, but you'd like it to be as hot as possible. And so this is why we burn our fuels as hot as we can, and we put our facilities next to the Pacific Ocean to cool them as cool as possible, because that maximizes our efficiency, it minimizes the exhaust we have to have for the amount of energy we produce, and it maximizes our money. And we want to maximize our money.